So the formulas will be given to you. You just got to know how to use them. And we saw last class period and the class period before that how to derive the or how where the difference formula came from and the sum of two cubes came from. But all you got to do is just be able to use the formulas. So the formulas are these. So if you have the sum of two cubes, remember when you factor the difference of two cubes and the sum of two cubes, it's a binomial times a what? Trinomial. And we saw that. And we saw that there's a relationship between the binomial and the trinomial so that it gives us the sum of two cubes or the difference of two cubes. And so do you remember what that binomial is going to be if I'm dealing with the sum of two cubes and this is F and this is L? F plus L, good. And once you find the binomial, then the relationship of the trinomial comes from F and L. What's that first term of your trinomial? Very good. What about the next one? Yep. Yep. You change the sign. And then plus what? L squared. All right. So some of you don't need the formulas, but it is there if you need it. Then the difference of two cubes, the formula, again, it's a binomial times a trinomial. And what is that one? Yeah. And then what else? All right. Plus FL, the product, and then plus L squared. And then all you have to do is be able to use those formulas. Now the difference of two squares you're going to have to know. I won't give you that one. Okay? So let's look at a few examples before we look at something new. So let's suppose I had this, and let's suppose I wanted to factor, number 1, 27x cubed minus 64. 27x cubed minus 64. So what's the first thing you're supposed to do with factoring? And remember, factoring started in the first part of chapter 13. This is the end of chapter 13. What did you do to do this? Look for GCF first. What is a GCF? 1. All right. Then what did you do after that?
See if those are perfect cubes.
Okay, very good. So he's noticing that there are how many terms? 2. There's a subtraction sign in the middle. And we've talked about 2 situations where there were 2 terms and a subtraction sign in the middle. Difference of 2 squares, difference of 2 cubes. Is this going to be the difference of 2 squares? No. For one thing, x is being raised to what power? The third. Well, if x is being raised to the third power, then don't check to see if this is 2 squares. Check and see if this is the difference of 2 cubes. Now remember, what you need to do to help yourself is do the work. So ask yourself, this is the difference of 2 squares if I can fill in these parentheses. If I can write the first term as something cubed and the last term, 64, as something cubed. Can I fill in the first parentheses? Yeah, so what times itself 3 times is 27x cubed? 3x. What times itself 3 times is 64? 4. So here's my F, here's my L. So is this right here the difference of 2 cubes? Yes. So then I just use my formula. So I can factor the difference of 2 cubes. So let's talk about the answer. I can factor the difference of 2 cubes as a binomial. And what is that binomial? 3x minus 4. Times the trinomial. All right, let's do the work for the trinomial. The trinomial part says I take f and I do what to it? Square it. Well, what is f in this case?
3x.
So 3x times 3x is 9x squared. So there's your first. What is the middle term? Is it going to be a minus or a plus?
Plus.
Plus. Then it says I take the first and the last and multiply them together. So what's the first?
3x.
What's the last?
4.
What do I get?
4.
12x. And then plus L squared. What's L in this case? L in this case is 4. And so 4 times 4 is 16. And so there's your answer. So you get 3x minus 4 times 9x squared plus 12x plus 16. All right, number 2. Suppose in number 2 you had 36x squared minus 49y squared. So 36x squared minus 49y squared. All right, so what do you do first? GCF. GCF, though. What's a GCF? What's a GCF? GCF is 3?
1.
GCF is 1, right? So then you notice there how many terms? 2. Subtraction in the middle. So do you think this is going to be the difference of 2 cubes? No, for one thing, x is being raised to what power? A second. So you want to see if this is the difference of 2 squares. And it is the difference of 2 squares if I can fill in these parentheses. What's inside the first parentheses? 6x. Because 6x times 6x is 36x squared. What's inside the second parentheses? 7y. So there's my f, there's my L. And remember, the difference of 2 squares is a product of 2 binomials. F minus L times what? F plus L. So the first terms and the last terms are identical, except the signs are different. So my answer then will be 6x minus 7y, or you could have said 6x plus 7y first, does not matter. But since I did say 6x minus 7y, then the next ones have to be what?
6x plus 7y.
6x plus 7y. All right, number 3. All right, suppose we had 8x cubed plus 125. 8x cubed plus 125. What do you look for first? What is a GCF? 1. All right, so then it's not a trinomial, it's a binomial. I have 2 terms. So what do you want to check for? Looking at what you see, what do you think you want to check to see if this is? The sum of 2 cubes. So always do this middle step, the work. So ask yourself, can I fill in these parentheses? What times itself 3 times is 8x cubed? 2x. What about 125? So this is the sum of 2 cubes. So since this is the sum of 2 cubes, I can factor it. All right, so let's factor. So this is the f and this is L. So remember to factor the sum of 2 cubes. It's a binomial times a trinomial. What's the binomial? The binomial is easy. What is it?
2x plus 5.
2x plus 5. Now the trinomial says you take f and you square it. You multiply it by itself. What's f in this case?
4x squared.
No, but that's the question though. What is f in this case? 2x. So I multiply by itself. So what's 2x times 2x? 4x squared. Now is that going to be a minus or a plus symbol?
A minus.
Minus. Then it says I take f and L and multiply them together. Again, what's f? What's L? So what do I get? 10x. And then plus L squared. What's L?
5.
5 times 5 is
25.
25. So there's your answer. All right, number 4. Suppose you had 4x squared minus 16 4x squared minus 16. All right. What are you going to do?
GCF.
All right, what is a GCF? 4. So I can factor out a 4. The GCF is 4. So I get 4 times x squared minus 4. All right, am I done?
No.
No, because one of the things you always got to check is to see if you can factor any further. So if I look at x squared minus 4, you know that this is the difference of 2 squares. So I can factor this further because x squared minus 4 I can write as x squared and 2 squared, right? So that's the difference of 2 squares. And so I can factor this then as x minus 2 times x plus 2. But don't make the mistake and say that's your answer because you factor out a 4. So this x minus 2 times x plus 2 is a factorization for this, but that was not my original. My original was this. So you remember you had to factor out a 4, so you got to put that in your answer. All right, now let's suppose though that you forgot to do the GCF. Let's see what would happen. And some of you on your worksheet that you got back, you didn't factor completely. You forgot all about the GCF. So let's say you forgot about the GCF here, number 4. So let's do number 4 again. But let's just assume that you did not see that the GCF was 4. But is this still the difference of 2 squares the way it's written? Mm-hmm. Yes, because I can fill in these parentheses because 2x times itself is 4x squared, 4 times itself is 16. So this, the way it's written, this is the difference of 2 squares. So f is 2x and L is 4. So when I factor this, I get 2x minus 4 times 2x plus 4. On your worksheet today that you got back, for some of you, and you probably saw this if you were in that situation, you got to look at these factors right here. Can I do anything else to 2x minus 4?
Yeah.
I can factor out a 2. So you'll notice that on the worksheet I did something like this, where I factored out and then I put parentheses there. Just remember that you could have factored out further. So 2 times what though? X minus 2. Over here, what can I factor out? A 2, and you get x plus 2, right? So how many, right now, if you look at this, this right here, it's read as 2 times x minus 2 times 2 times x plus 2. So how many factors do you see all together? How many factors do you see all together? 4. 2, x minus 2, 2, and x plus 2. But I know, remember all this multiplication, right? The order which you multiply does not matter. Multiplication is commutative. So I know that 2 times 2 is what? 4. So I expect you to say 2 times 2 is 4. So you get 4 times and then these two factors. X minus 2, x plus 2, which is what we had here. All right? So always on your test Tuesday, just make sure you look at your factors in your answer, and you gotta ask yourself, can I go any further with it? All right, and then finally, let's look at number 5. Suppose in number 5 you had this: 4x squared plus 16. So a while ago we had 4x squared minus 16, which was the difference of 2 squares. And if you look at number 5, what do you notice about number 5? Huh? What would you say? Okay, so it's the sum of 2 squares, right? And what do you remember by the sum of two squares?
You can just factor and you cannot.
It's prime.
But you can factor them, right?
Yeah, hold on. It's prime, right? So if you had x squared plus 9, which you won't because that's too easy, what would you say on the test? Prime. Now you're not going to have any primes on the test; they'll all be factorable. But so this is the sum of two squares, right? And we saw the sum of two squares cannot be factored. This is the sum of two squares, but don't say it's prime because I can factor this. What was the first thing you always should do? GCF. What is the GCF?
4.
4. So what's the answer?
4 times x squared plus 4.
And you're done. You factor. That's the answer. Don't say the answer is prime. Because factoring, first thing of factoring is to factor out the GCF. If it's other than 1. Now, x squared plus 4, can I do anything else to that? No. Compare that with this one where I had x squared minus 4. See right here? Could I do anything else to that one? Yes, because that is the what? Difference of two squares. So compare 4 with this. So x squared plus 4, x squared plus 4, that's the sum of two squares. Okay, I cannot factor that, so you're done. All right? Okay, so that was a quick review from a previous lesson. That is on your test, Tuesday.